first of all, we will be discussing about Docker and then Kubernetes, right? Who should join this course? And like, beginner who wants to learn Docker and Kubernetes in advanced level, and who is preparing for CKA or CKAD. Basically, I covered, both the course content, CKA and CKAD is covered in this course. So that will be helpful to attend your or to do your certification, right? A bit about me. My name is Anish Ansari. I'm having 10 plus years of experience from last 5 years. I'm into this ed industry, education industry. I'm corporate trainer basically. I trained more than 1,000 people online and by visiting campuses to multiple companies, big brands, CM level 5 companies, and their um, candidates, new joinees, and experienced people when it comes to my primary skills. Those are Docker, Kubernetes, Linux, Jenkins, most of the DevOps tool, right? Because I'm currently working senior DevOps engineer. So, yep, that was about me. And I believe after completion of the course, you guys can attend uh, whichever is required certificate for you, CKA or CKAD. Now, we will be discussing about small guidance for CKA, who should go for CKA and who should go for CKAD. If your job role is platform engineer or somehow right, SRE or DevOps engineer, right, where you are going and configuring and creating environments, then you should go for CKA, not for CKAD, right? CKAD is for the people who is not going and creating environments. Environment is already created, and you are just doing monitoring kind of stuff, or you are a developer, right? You are developing the application. You should have knowledge of how applications are being deployed on Kubernetes cluster. And if you want to write your own YAML files, you want to deal with few of the Kubernetes object like deployment, secrets, config maps, so then you should go for CKAD, right? CKA is more focused for architects, where you are creating clusters. Anything goes wrong with your nodes, you are troubleshooting it, you are making that node up and running, right? So I believe that you can have option which one to choose for you, right? Now, we will be discussing about that, what all things we are going to cover in this course. We'll be starting from basics of Docker. Everything will be from scratch. Slowly, we'll be moving forward with advanced topics, right? So, what is Docker and what exactly Docker is, how to create containers, right? We'll be discussing about few of the things related, container D, Docker. See, we'll be adding here Cryo, right? And installation of Docker on Ubuntu. Most important part, we will be doing this on AWS account. You need to have a AWS account uh, or a VM virtual box you can install on your local laptop, and you can make it work. If you are okay with the cloud, then we'll be using AWS, right? Installation of Docker on Ubuntu, on your EC2 instance or your virtual machine, where Docker is storing its all the configuration and the container on your local machine, we'll be looking that one, checking the version, few basic commands to create Docker containers, list them, how many containers are running, how many is paused, how many of them is stopped, right? Such commands will be executing it. You're understanding Docker architecture, right? Where we'll be discussing about Docker daemon, which is Docker server, right? Docker client, talking about Docker image registry, right? How images are being created, container is being created, how we can manage them, how we can delete them. Services is nothing but Docker Swarm. It is under Docker Swarm basically. Underlying technology of Docker is a theoretical part. How Docker containers are getting created and all is a theoretical part we'll be looking into. And see how we will be pulling in the image from the repository, how we'll be pushing image from particular repository, correct? Create container by newly created images. Basically, when it comes to image part, Docker file, how to write Docker file to build a Docker image from the scratch, that part will be covered. Each and everything is mentioned in this document in the course content that will be shared with you. Networking, Docker networking is nothing but how your Docker containers are getting IP address assigned to it, and right, how to create your own private, your own custom network, right? And host network, what exactly it is. If your container wants to use host network, talking about host network, right? And what is overlay? Overlay is basically it is for Docker Swarm, nothing to do with MAC. It's a type of the network. And when it comes to storage part, persisting the data, so what type of volumes are available in Docker, that we will be discussing here. Bind mount, volume mount, and dampfs. We'll be diving it in deep to understand these type of volumes. Backup and restore images, converting them into file format, image to file and file to packets, image and then create the container. That part is also there. As I discussed, building image by writing a Docker file, we'll be learning about that, correct? And creating container again by using that newly created image. We are having multiple registries available for Docker, right? Docker Hub, GitLab, GitHub, JFrog Artifactory, Harbor, and number of. Few of them we will be discussing here, which will be Docker Hub and GitHub, and the common practices which makes things easy for us to work with any type of registries like Harbor or JFrog or whatever it is, right? So common practices we'll be doing here with this registries, because it's not possible for me to go for each and every type of registries. But after diving into this topic, you will be able to work with any type of registries that you are seeing in your project or somewhere. Securing Docker, nothing is mentioned here. Okay, so overlay network with Docker Swarm, Docker Compose. In Docker Compose a part of Docker. Once we are starting Docker Swarm, so we will be learning about orchestrate your containers in highly available environment where we'll be having multiple nodes, how to deploy or image with multiple replicas of it. And Docker Compose is used in simple Docker, right? And instead of Compose, in Docker Swarm, we are having Docker Stack. That also I will be trying to cover. Not trying, that will be covered only. And finally, um, these are some type of examples: WordPress, MariaDB, or MySQL. Something we'll be looking at that practically. And these are prerequisites. Basically, you should know JSON and YAML concept. You should already aware of this. If you don't have idea or knowledge, no need to bother. I'll be covering that part. Now, finally, guys, we will be starting Kubernetes after Docker. Why we are doing Docker plus Kubernetes? This is the question. This should be the question, right? So basically here, Docker containers we will be creating through Docker. We'll be learning about application containerization using Docker, and then to achieve highly availability by using those containers, right? Those Docker container basically. How we can achieve highly availability, application deployment with the required additional features in Kubernetes, right? So that we can achieve highly availability, we'll be using Kubernetes, right? Kubernetes is an orchestration tool, and okay, I'm not going to discuss that more theoretical part with Kubernetes. Just look into the course content, then we'll be starting about that. So here, what all things you will be looking into: your architecture, your Kubernetes architecture, and its component. What all components we will be having in our Kubernetes. So that will be talking about Kube API server, controller manager, scheduler, CNI plugins, Calico, Flannel, or VNet, or Cilium. We're looking into Cilium, core DNS, right? etcd, kubelet, and finally your Docker engine, or alternatively we can use another containerization tool. Here we can use containerd or cryo, right? So cryo is the latest, the one which is adopted by most of the project these days. So I believe we'll be going with cryo, right? On your another nodes, similar component, kubelet, kubeproxy, things will be there. We'll be discussing about this, all the component, right? And deployment of Kubernetes cluster. So um, we will be creating Kube ADM cluster. Okay, what exactly this Kube ADM cluster is, that we'll be talking about, right? Generally, you might hear about Amazon is having EKS, and Google is having GKE, and Azure is having AKS. So these are cloud Kubernetes, and the cluster we are covering will be Kube ADM cluster, which is nothing but similar to on-premises Kubernetes cluster. And that approach, that type of cluster will be asked in exam. You will be dealing with in your exam such cluster. So that is the reason, guys, ADM cluster we will be creating, where we will be having one master node and a two worker node, right? We will be having one master and we will be having two worker nodes. In these worker nodes, we will be, let me make it note here, master node. Yep. So master node, and this is worker one, worker one. This will be, so this will be the master node. This will be worker node. Here we will be installing all those master node component like Kube API server, etcd, right? Our CNIs and our um, all CRI, container runtime interface. Everything will be installed here, and this kind of architecture we will be creating. And once Kubernetes is started, we will be seeing the differences between cloud Kubernetes and Kube ADM cluster, which is nothing but kind of your on-premises cluster, right? Where here in Kube ADM cluster, each and every component you will have to install. You will be taking care of it, its updation, its patching, and all. In cloud Kubernetes, what happens is cloud provider will be taking care of those things. You no need to do anything, right? After that, we'll be started talking about what exactly is pod, how to create a pod with single container, with multi-container, right? So pod, we will be discussing static pod deployment and how to assign CPU, memory, right? How to deploy application from registries, different registries, what exactly init container is, different type of pods we are having. So we'll be discussing all of them, right? Most of them will be covered, nothing will be left. And after that, a pod is a single unit basically. To achieve highly availability, we'll have to create a pod using a replication controller or replica set or deployment. So basically, these objects will be helping you to create your pod's multiple replica. Replication controller came very first of all. After that, they implemented replica set, and after that, they implemented deployment. So finally, we got deployment, and everywhere in our organization, we are using deployment object most of the time, right? So these objects will be helping you to uh, replicate your pod with defined number of replicas. First thing. Second thing is that they initially this is kind of a first release version, then version 2 was replica set, and version 3 was a deployment. Deployment is more advanced object which will help you to perform rolling update, rollbacks, maintaining the history of your previous upgradation or rolling updates, that we can look into this deployment is the most important one which is used everywhere, right? So we will be talking about these all things, these all objects in detail. Apart from these three objects, we are having one more object called daemon set. Daemon set is basically used to create um, you know logging and monitoring kind of deployment, logging monitoring kind of application. If you want to deploy in your cluster where you want to collect some of the matrices or logs from each and every node without defining number of replicas. So daemon set will help you. Daemon set will be creating pod in each available nodes, right? Based on a node, number of pod will be created and each pod will be placed in those nodes, right? So that is the importance of daemon set that will be diving in deep, right? Once we are starting it. Stateful set is one more object which will help you to deploy stateful application. So guys, what exactly stateful application is? Anybody wants to add something here? Yeah, Ahmad, Ramakrishna, Anand. What is stateful and stateless? A general term. Okay, no worry. You should you should talk actually, so that in session also, if you're having doubt or question queries, you can ask me meanwhile, right? No worries. Stateful application and stateless application. Stateless applications are the application which is not maintaining the state or something. It is not like database driven applications, right? Stateful applications are application which is database driven application, right? So such kind of application, if you want to deploy it, then you have to go with stateful set. Stateful set is something very important topic that interviewer will be asking you each and every time during your interview, right? And even once you are going to work, you might be seeing this object. This object is important because when you want to deploy database cluster within Kubernetes, then you can do this through stateful set. We will be having multiple pods, right? Generally, deployment, just take a small overview of stateful set here. Let's say you created few of the pods here. Few pod created here, few pod created here. We can assume that these pods are created using some of the deployment. These are the deployment pods. Some application pod, we can assume that. And whenever you want to talk to this pod somehow while being in this pod, if you want to talk to this pod, you will have to create a service. That is well and good, right? You can create a service. When you created these pod using deployment object, where you are having multiple replicas and you want to connect with a specific pod, that will not be allowed. Okay, through deployment pods, it will not be allowed. And whenever we are implementing cluster inside cluster, means Kubernetes is already a cluster. In this, you want to implement your MySQL cluster. Generally, it is not recommended to deploy your application with cluster inside cluster. It's better to create your database cluster outside and then call that cluster in your Kubernetes cluster, right? So then generally we should practice like this way. Keep your cluster, database cluster separately, and then communicate with it wherever it is required. If still you want to keep in Kubernetes cluster inside cluster, then stateful that will be helping you out. So stateful set will help you on that, right? Generally, deployment will not be allowing you to communicate directly to a specific pod. Deployment will be sending your request a random pod. Okay, it will be choosing the pod by its own. But if you want to choose the pod by your own, then stateful set comes into the picture. With the help of headless service, you can do that. We will be implementing this practically. Okay, so we'll be looking at once this topic is started. Stateful set is important with a point of volume as well. Stateful set is so powerful, it can spin up or it can create volume for each of its replica. Okay, whenever you will be creating a replica, so in a stateful set, it can dynamically provision the volume, right? When it comes to volumes in Kubernetes, we are having different type of volumes. Majorly discussed volumes are empty directory, host path, and persistent volume. Whenever we are talking about persistent volumes, so we are having static volume provisioning and dynamic volume provisioning. What exactly those static or dynamic provisionings are? Static provisioning is used in EBS. Sorry, I'm really sorry. Static volume provisioning basically is used for NFS or some of the network volume, right? Dynamic provisioning is everywhere these days. You no need to go for static volume provisioning. Dynamically, volume will be spun up in your cloud account. How it happens, we will be implementing it practically. No need to bother about it. Basically, PV and PVC and storage class, persistent volume claim and storage class. What exactly these are and how they are related to each other, those things will be covered while we will be going through the session. We are having different type of services, guys, to access your application outside of the cluster, to communicate your application within the cluster. Means I'm having a front end application and I'm having a back end running inside the cluster, and if I want to communicate from front end to back end, how communication will happen? Through cluster IP service. If my application is running, I want to access this application from outside of the cluster, from the internet, then we are having another options. We can go with the node port service and we can go for the load balancer service. External service, what exactly this external service or external name is something. As I told you, my database cluster is running outside of my Kubernetes cluster somewhere, and from inside the application, I want to connect to my DB database cluster. Then this external IP, external lane things comes into the picture. We're looking these things as well, right? What exactly secret is, what exactly config map is. Config map can be used in form of environment variable, in form of files, can be using volumes, right? So config map is nothing but keeping your configuration in centralized place and call the same configuration for multiple deployment. That is a config map. We'll be covering it. Secret is nothing but your certificates, your password, username. So how to keep your this information separately from application, and then when it is required to call an application, that will also be covered. Ingress controller, something, something is important. Generally, whenever we are creating node, whenever we want to access our application from outside of the cluster, so I told you node port and load balancer. Node port service or load balancer service is having a drawback. What is that drawback? So drawback of those services, what happens is node port service, it will be using IP address and the port number, which is difficult for our users to remember. In case of load balancer also, our customers will not be able to remember IP addresses or huge load balancer names or addresses, right? It is not possible. People can remember domain names, google.com, facebook.com, anish.com, right? They can remember easily. To access your application through domain names, ingress comes into the picture. Not only domain name, but routing paths. Ingress controller comes in the picture. We are having different type of ingress controllers, Nginx, HA proxy, and many. It's a huge list. We'll be using Nginx, right? Talking about ingress. And let's give me a minute. Huh? I need a minute. Yeah. So horizontal pod auto scaling, HPA, we discussed about somewhere here deployment. So this part should be discussed at that time only. So guys, what happens is, let's assume that my deployment is running and suddenly I start getting more requests towards my pods in deployment, right? What will happen if too many requests started reaching to my pods? Sometimes there is possibility it might not able to serve those requests, and in this situation my pod will be started crashing. So how HPA will help you? Auto scaling, basically the feature of auto scaling of your pod, in simple word. Once average CPU utilization is getting increased of your pods, so HPA, horizontal pod auto scaler, will be adding more number of pod to the deployment, so that whatever request is increased on our application, those can be served. And as soon as a request is going down, so what it will do is additionally created pod will be deleted. This is the this is the functionality of HPA based on CPU threshold. It works. We'll be implementing it practically. What exactly HPA is? It works with deployment object, basically, and scheduling and the probes. Probes are nothing but checking the health of your pod. If your pod is not well, those will be killed and recreated. Continue generally. Different type of probes we are having: readiness probe, liveness probe. I'm not able to see those are, yeah, these are mentioned here. See, readiness probe, liveness probe, startup probe, right? With different type of events, we can invoke them, right? We can perform the health check of our container, correct? What exactly readiness is, what exactly liveness is, how it works. We'll be talking about that too. When it comes to the scheduling, means you will be having multiple worker nodes, and you will be choosing which node. Sorry, in scheduling, you will be choosing in which node my pod should be scheduled. We are having different type of mechanism or different type of schedulings that we can do based on the node name. We can choose the node my pod should go and get deployed in a node which is having this name, some name, right? And node selector as per the name. your nodes will be marked up with some of the labels, and based on the node label your pod will be deployed in that. Here it will be. And pod affinity, if pod is running in some particular node, this new pod should go and get created with that node, right? So that is called pod affinity. Pod anti affinity we are having. My pod should not go and get deployed in a node where some type of pods are already running. I don't want to go with them. I will be going separate, just opposite node. Pod anti affinity. Node affinity and node affinity. Node affinity means I am choosing the node. A node which is having this label, just go and get deployed this pod in that. So it will be going and getting deployed there. Node anti-affinity. Don't go and get deployed in a node where your node is having particular label added on it. I know this one, you might be thinking that, okay, this is something complicated, and most of the time it is complicated only. So you don't need to bother about that. Everything will be implemented practically, and using diagram, I will be trying to make it easy for you, right? One more thing should be mentioned here called taint and toleration in this part of scheduling, which is not mentioned. I will be covering taint and toleration as well, because interviewer will ask you everywhere, right? This taint toleration is important apart from this, so that will be covered. And if you want to execute some jobs in Kubernetes, or you want to perform cron jobs, cron job and job is a different. Job is something to like, achieve something, to execute, right? To push some data or pull data from somewhere, Kafka queue or somewhere. So then jobs will the option. If you want to perform some of the activity on given time, then cron job will help you guys, right? Cron job will be helping you. Calico networking, like say in simple term, pod networking. Let's say for an example, I'm having um, I'm having this green pod and this red pods are deployed here. So what I just want to do here is I want to make sure that, yeah, what I just want to do here is I want to allow only green pod to talk to this red pod. Some kind of network policy implementation. Other color pod should not be able to talk to this red pod, right? So such kind of policy implementation will be covered over here. We'll be talking about that part as well, right? Authentication and authorization in Kubernetes cluster. Let's say you are an administrator of a cluster and you want to assign some permission to your colleagues based on their job role. They might be application owner, they might be auditors. Owners will have full privileges, auditors will have only view permissions, right? How you will be implementing this in Kubernetes? So with working with RBAC, role-based access control, its full form is, we can provide access to the people in Kubernetes cluster. How to do this? We'll be implementing it practically. Kubernetes is having its own dashboard. We can access it visually from web browser, and we can create application deployment. We can see what all objects of Kubernetes is running in our cluster, like deployment or secret or config map or the services, and so many things that can be seen and managed through the dashboard. But this is not a good practice to run dashboard in your environments. Every time you will be dealing with the CLI command line interface only, but still we will be talking about dashboard too, right? And after that, taking the backup of etcd and update a Kubernetes cluster version from one version to another version. Obviously, 1.20 is older version, so we will be going with the latest version. Let me tell you about that too. Okay, Kubernetes.io. Let's go here. I'll tell you. Latest version is 1.30, 31, sorry. See. So what we'll do is we'll be creating cluster of 1.29 or 30, one or two version below, and then we will be performing upgrade of 29 to 30 or 30 to 31 something. Any version we can choose it. It doesn't matter for me, right? Changing the version is a huge thing. There might be so many complications sometimes. So we will be diving into this kind of cluster upgradation with the version here. Taking the backup of etcd means complete cluster backup and restore it. Using cron job, that I'm not doing cron job through cron job, I'm doing it manually. If you want to do it, you can do that as well because cron job is also covered. 1 minute, guys. 1 minute. Yes, guys, I'm back. So, we are discussing about these things, right? So, guys, apart from all these things, see, there, uh, 10 toleration is mentioned here somewhere, but that will be covered. So, obviously, data with persistent volume will be covered. And Helm chart will be started here. What exactly Helm chart is, how to create your own Helm chart, how to perform rolling update and rollbacks from the Helm chart, how to see the history of your deployment using Helm chart, right? And how to store it in some of the image repository, everything related to Helm chart. Not every, most of the thing through most of the thing from Helm chart will be covered over here. We learning that how to create our own custom Helm chart, how to package it, how to store it to the repository, GitHub basically, and how to call it in our local environment, right? What exactly values.yaml file is, what is a chart.yaml, helpers.tpl, right? Directory structure, these things will be covered. You don't need to bother about this thing. Helm chart, and after that, I added not EKS thing. It is not added EKS. It's for previous session, custom training. And Ergo CD will be added over here. Ergo CD, where we will be learning about continuous deployment using Argo CD will be here. So that's all about the course content, guys. It's a huge course content, daily 1.5 hour. We will be investing in this training so that we can take advantage of this in our workplace or to clear the interview. And yeah, so most of the example that I'm going to do or implement in our training session will be based on real-time scenarios, and everything will be practically 95 to 90 to 95% will be practical implementation of each and everything will be here. So yes, guys, if you guys are having any question queries regarding this, please ask me here. Yes, Ahmed, Ramakrishna, Anand. Do you guys are having any question queries regarding this course content? You can ask me. Yeah, be interactive.
Yeah, hi Anish, Anand here. So
Yes, Anand.
this course also like Kubernetes certification we can do, right? So after this complete of this course, right?
Yes, after completion of this course, you can do certification. If you need help from my side to complete this certification, CKA or CKD, I am not promising, but I'll help you to get some dumps. And one
Okay.
more, and the most important thing related dumps I want to discuss here is from 12th of September, um, when it is like CNCF is about to change the exam pattern. So don't rely on the dumps at that time. You need to rely on your own skills, your practices. That gonna help you. Dumps
Mm-hmm.
might not be working because they are changing lots of things now in 12th of from this 12th of September this year.
Okay.
Yeah.
And
Have you been?
For Docker any separate certifications is there?
Docker is the lower thing. You are having
Mm-hmm.
certificate for Kubernetes, then it's not required at all to have Docker
Okay.
certificate.
Mm-hmm.
Right? If you are doing masters, then obviously people knows that you did graduation. That only you are going for post graduation, right? They will not ask you.
Okay.
Yes, Ramakrishna, any question you have?
What are the required softwares we need for Docker and Kubernetes?
Docker and Kubernetes. So basically, a required software is nothing. Everything is freely available on internet. Docker
Mhm.
and the Kubernetes, KubeADM, kubelet, kubectl. There's a list of the component that will be shared with you. How to
Okay.
create the cluster. Yeah. Only the thing is that when it comes to implementation of this thing, you can go for your AWS free tier account. And I'll not suggest you free tier because free tier might not help you because T2 micro instances will not be working properly. It's better to go for AWS T2 medium instances, which can cost you a small amount of bill, 100 200 rupees most, if you will be just dragging it to 500 rupees, not more than that, only in a situation while you are practicing and deleting it. After practice, delete the resources whatever you created. If you keep running it, it will be increasing huge amount of bill for you, so don't do
Okay.
this.
Azure, I
If
have
you
account.
want,
Azure, we can do. On Azure, we can do this.
yeah, Azure also we can do that. It will be. And another thing that I want to discuss is that still you want to go for 100% free resources, you can install VirtualBox on your local laptop and you can create instances. But to do that, your laptop should have at least 16 GB of RAM and 4 cores of CPU. In Kubernetes, it can trouble you to uh, making it down system performance. But still, I'm having another option. I can give you free lab where you can practice it. That is also the option we are having. But free thing is free. Sometimes it is available, sometimes it is not available. Based on the luck, it works. Right? You cannot store anything on those apps. You cannot store your data there. So, yeah.
Okay.
Anything else?
So every session recorded and the recorded sessions will share to all, right?
Yes, recorded session will be shared to all on the daily basis. And let's assume that you guys are practicing after the session, right? Because it is 1.5 hour session per day, and you are practicing in noon or night or somewhere, and you are getting some error. How you will be resolving that? You no need to bother. You'll be creating WhatsApp group and you can post your queries or questions there in WhatsApp group. I will replying you based on my availability.
Okay.
Right? Sometime I'm traveling, sometime I'm driving, or I'm in meeting. So those times I cannot reply. But after that, I will definitely reply. Yes.
Okay.
Yes, Ahmed. Nothing to discuss. You don't have anything. So, guys, in today's session, just we discussed about the course content. Most probably in upcoming sessions, we will be starting things from the Docker, right? So this is it from my side. If anything is pending, if anything you want to ask, any question queries, you can please ask me now, or we are ready to wind up the session. Nothing. Okay. So I believe we are ready to leave. We are ready to wrap up the session. So let's connect tomorrow most probably. And yeah, that's all.